Welcome to the extension, I guess, from 2 dimensions to 3 dimensions with regards to vectors. So once you finish your work with vectors, you pretty much, hopefully, will be comfortable in the 2-dimensional sphere, okay, of vectors. But of course, vectors can extend not from just 2 dimensions, but to 3 dimensions. And in fact, if you continue to study math and sciences, engineering, or some of the other programs, maybe physics, you're going to be extending vectors to n dimensions, so to as many dimensions as you like. Now, the problem for us humans is that we can certainly visualize 2 dimensions, we can visualize 3 dimensions. Beyond that, it's a little bit tough. So people maybe have a little bit of an abstract viewpoint, but this particular video is going to just pertain to introducing you to vectors in 3 dimensions. So luckily we can still manage a little bit. It's hard to do it on a 2-dimensional screen to be able to see vectors, but as you can see here, I have plotted out so your x and your y, and then I've added an extra z. So this would be our 3rd dimension that we're going to be utilizing. You can see there at the corner, so huge thanks to math3d.org, which I do utilize for visualizations in 3 dimensions. You can certainly use their website. I will do so. In this video, I'll show you because it's a lot nicer and easier to be able to have a grasp in kind of a visual aspect of these 3 dimensions. So what am I going to cover? Well, I'm going to try to talk about a few things in here. So I want to be able to extend the point from 2 dimensions to 3 dimensions, and I want to extend the vectors from 2 dimensions to 3 dimensions. So that's the first item that I want to be able to discuss. I want to then introduce an extra unit vector, which is one of our kind of base vectors. So you may recall in 2 dimensions we had the I and the j vectors, and we utilize those. Well, shouldn't be really a surprise. If you go into a 3rd dimension, you're going to have another unit vector. So that unit vector we actually call the k vector. So I'll talk about that. So that shouldn't be too big of a deal in terms of extending it from 2D to 3D. You can express any vector. So I guess building up on point 1 there. Okay, you can certainly express any vector in terms of those unit vectors like you did in 2 dimensions. And then lastly, I want to be able to just remind you, if you're going to be taking 2 points, so point 1 and point 2, and you want to find the vector in between them, you can certainly do that. So rather easily, especially if you are using vectors in the Cartesian vector form. Then I will finalize the video with regards to talking about the magnitude. So all of these are an extension from 2D to 3D. And to be honest with you, they extend to the n dimension as well in pretty much the same fashion. So let's dive in here. So the first idea is with regards to points and vectors. So now if you recall, if you're going to be studying points and vectors in 2 dimensions, you knew that you can write them out, certainly, okay, in terms of points with your round brackets. We can plot a point in terms of the Cartesian plane. Well, all we did with regards to vectors, instead of using round brackets, we started to use square brackets. So for instance, if you wanted to plot a point, you can certainly say the point 1, 2, where you would have your x and your y axes. And then if you really wanted to change this, instead of having a point and you wanted to have a vector, you know that you could have written it out in vector form in this way. Now, what's interesting, in 2 dimensions, we use geometric vectors, right? Where we would have a magnitude and, for example, an angle, okay, or some kind of a direction with respect to some kind of a coordinate system. In 3 dimensions, you can still do that. You can certainly provide a magnitude and some kind of an angle, but it is much harder because now what is the angle with respect to, because it's 3-dimensional, so it's not as easy in terms of talking about north, south, because you do have a third dimension in there. So what we actually tend to do is we like to utilize the vectors and switch them back into their Cartesian form because it's just so much easier to be able to deal with. And that's exactly what you're going to be finding when you're going to be studying these vectors in 3 dimensions. So within this, if you plotted this out, this point or this vector, it was rather simple to be able to do that, right? Because it was directly in a plane. Now, if we do extend this, and we extend this to 3 dimensions, well, we can have points in 3 dimensions as well. Now, the only difference is that if you're going to have a point, it's going to have an x value, it's going to have a y value like before, but it also is going to have a z value. And the z value, by convention, so as we have it right here, you'll notice that your x kind of is moving in this direction, your y is moving in this direction, and your z is typically up. This is one of the conventions that actually deals with the right-hand rule. So what happens is, with regards to your right-hand rule, so as you kind of wrap around, so as you're going through, your thumb is pointing in the Z, okay, axis, and then you are going along your quadrants, okay, as you had your X and your Y, so you would be wrapping around this way, okay. So instead of, for example, you know, if you wanted to, you know, if you don't go this way in terms of right-hand rule where the thumb is down, you go in terms of the positive values, okay, of your third dimension being up, and then your X and Y is actually now a plane, like a surface which is flat down. Instead of on an actual surface like this, we just bring it down in this particular way. So we can graph points as we like in terms of X, Y, and Z. And then we can take the same thing, and if we wanted, instead of plotting just points, we can plot these in terms of vectors where the tail would be at the origin, like we did with 2 dimensions, right? It starts at the origin, and then you can plot it out anywhere else, although you can certainly translate those vectors wherever it is that you like. And now, if it was a vector, well, then we utilize the square brackets, and we have the actual components of our vector associated in this particular way. So the X, the Y, and the Z. So I just want to give you kind of a visual, okay, of this. So for instance, I am going to go back and forth. So this is actually what we have, okay, with regards to math3d.org. And I have utilized Desmos throughout. Now, Desmos is not actually 3-dimensional, at least not yet. So I really like utilizing math3d.org to be able to visualize these concepts. So it's the same thing on the left-hand side. It's a little bit maybe different because you can add your components there. So for instance, if you add a point, okay, it will draw a point for you. So notice you have a 0, which is plotted out there. You can change, you can certainly make the size bigger. So if you go to the settings, okay, within here, you can make that point bigger, okay, and bigger, and so on, just so that it really pops out there for you. And you can label that particular point if you wanted to, okay, within there. And now it does use the square brackets, okay, if it populates it for you, but notice right above it, it does say point on the left-hand side. So if you wanted to shift this point, for instance, notice the X, the Y, and the Z axes. So if I wanted to shift it, okay, over, let's say maybe it was 0.300, so 3 is your X value, 0 would be your, so your second, the 0 in the second spot is your Y value, and then the third value is always your Z value. Now, it is definitely harder to be able to do this, okay, if you're going to try to actually plot it out and then visualize. So notice if I put maybe 3, 3, it shifts this over, notice, in that particular plane. So now you can look at the X, it's 3, look at the Y, it's 3, and then you can bring it down, the Z is 0. Now, as soon as the Z becomes something else, so let's say if I maybe also made it 3, it does shift it out. Now, what's really neat, like you had in Desmos, where you can kind of zoom in, zoom out, here you don't only zoom in, zoom out, you can actually rotate these. So notice if I grab this, okay, and kind of shift it over, then I can actually rotate this through. And this is going to be rotating around so that I can visualize this kind of being at the point 3, 3, and 3, right? So I can do that. I can bring it back down to the plane. I can bring it back down, okay, to the x-axis. And these particular shifts, you know, you're going to be able to do it. I'm using a tablet in here, so my iPad. But if you're using it on a regular screen, you know, you can use it with the mouse and then actually shift it back and forth, okay, as much as you like. So that is, okay, how you would actually plot a point. Now, if you wanted to plot an actual vector, so I'm going to put, notice in here, it has a vector option, so you hit vector, and now notice it draws the vector in there, but it draws it from the origin. So I'm going to actually draw it so that it's associated with that particular point in there. So notice that it draws out the vector, which is 3, 0, 0. And that's pretty neat. You can certainly draw other vectors, and indeed, if you're going to start drawing vectors that are, okay, kind of in the three-dimensional space, it's going to be much harder to be able to visualize this in some particular way, okay, as you're going through. But, you know, I mean, I can kind of rotate this around, and then you can see that it's being shifted around in there, you know, so in terms of how you would want to be able to view it. So notice that if I go in this way, right, so this is kind of neat to be able to see that particular vector and then shift it around, okay, within there. So that's how you can plot these within, and those vectors are actually plotted out for you in here. So I'm going to go back. So that is not a huge change. The change is just getting used to be able to actually see these in a visual form in terms of 3 dimensions, and that's definitely much harder to be able to do that. If you're going to be doing it by hand, you can certainly plot this out on your own, okay, and within here, so you know, you can certainly do this. So if I was starting it off in terms of a fresh, okay, from scratch, and maybe your teachers were asking you, you know, to do this, so very often, okay, so what I like to do is I'll put up, okay, straight arrow up, that's going to be my Z, okay, and then to the side, okay, I'm going to put my X, okay, and then here, this is what I like to do, and this would have been my Y. So I like to go Z, so this is my X, this is my Y, and then I can actually start plotting this out in 3 dimensions as well. And maybe you're going to be doing that, okay, with points. So within here, so if this was 1, this was 2, this was 3, then I could put my point, so the one which I put in there, which was 3, 0, 0, you know, I can certainly do that. Sketching it out in terms of trying to do it, okay, on a sheet of paper, it is definitely much harder to be able to do that, okay, as you're going through. So what I recommend is, if you, for instance, had the point, and this was, let's say, the point 3, okay, maybe it was 2, and then maybe it was 1, then what I would encourage you to do, so as long as you can kind of write these out, okay, hopefully in a nice, relatively nice way. So notice that within here, so what we would have to do, I'm going to kind of dot it out, okay, within. So you have, so within here, so this is going to be your 2, and it has to be parallel to that x-axis, right? So as you're drawing this out, okay, it has to be parallel within here, and then this point, okay, so it would have been something along there. That would have been, okay, how you would have shifted. So you start with the 3 on the x, then you go along the y, which you create a 2, so now it creates it in a plane. So now for this one, this would have been shifted over here. That is in the plane. This would have been the point 3, 2, still 0. And then, you know, if you want to raise it up, so this is now the much harder component. So as you have it 1, 2, 3, you know, you would have to raise this up, okay, ever so slightly, okay, up above here, so that it looks like it's kind of floating in there. And that would have been your point. Okay, so this would have been now shifted over, okay, and it's kind of the three-dimensional point, the 3, 2, 1. And if you were trying to draw that vector and it was starting its tail at the origin at 0, you would have just literally, okay, drew this vector, okay, within there, okay, and have done something like that. And notice, much, much harder to be able to do that, and much nicer to be able to do it on a tool, something like this, where you can actually visualize it for yourself and then turn it around, right, to be able to see that vector, okay, coming up, coming down, okay, within there. So that is pretty neat, okay, in terms of the tool that we have. All right, so those are vectors in 3 dimensions. I think you definitely do understand what that concept is. Now, if you're going to go back, so this is point number 2, you will recall, so we've done this one, you will recall that these vectors, these unit vectors, the I and the J, there was nothing really special about them as you had them. Now we're introducing the K. Well, the I vector, okay, so as you have, so my I vector that I have is nothing else but simply the X value. And now because it's 3 dimensions, so this actually gets, okay, moving in this direction. This is my unit vector along the X. The J vector is going to be the unit vector along the Y. So that is nothing new, okay? This is the same thing as we did have with regards to the plane, the 2-dimensional plane. And then finally now the K vector that we have, so this one is simply just now along, okay, the Z axis, okay, which is now upwards, and that would have been the actual plot in there. And you can certainly label them if you wanted to. I can remove this, okay, just so that it's a little bit nicer and cleaner, okay, in here. Those are your I, your J, and your K vectors, and you can plot them out. And in this case, once you have them, you can certainly take any, so in this case, this is a point, but if we had a vector, so within here, so let's say if we had the vector 3, 2, and 1, then in order to write these out in terms of your I, J, and K components, well, this is nothing else but simply 3I plus 2J plus, okay, in this case it would have been just 1, although we wouldn't really write it, and this would have been just 1K. And that's the exact same thing, so it's just the addition of the components from your X, Y, and Z values, or Z values that you have of your vector. And you can certainly see and be able to graph these. Now, you can add this, so if you're using and go back to math3d.org, you can certainly plot these out, and you're going to be able to see these vectors for yourself. So notice the components that I did in here, so the component of X, component of Y, and component of Z of any vector, okay, that we would have. So let's say if this was vector V, and this is what it was equal to, we can write it in terms of its components and the actual unit vectors that we have. So the pushover from 2D, once you have done that, to 3 dimensions, it seems rather, hopefully rather obvious, right? It's just a little bit harder to be able to draw and visualize in 3 dimensions, but we still can do it. Now, the last component of here, in terms of something that you should be aware of, if you are given 2 points, okay, so right here, so if you have 2 points that are actually given to you, and you want to find the vector in between those 2 points, so let's say this is point number 1, so let's make this x1, okay, this is going to be y1, it's going to be z1 or z1, so that's point 1, and let's make this point number 2, I'm going to call this x2, y2, and then finally z2, so those are my actual points. We can certainly plot them, and if you want to know what the vector is between point 1 and point 2, so the way that we write it out, if you write this, p1, p2, So this would mean the vector from P1 to P2. And the way to find it, okay, you would just simply take the components. So this would have been x2 minus x1. So that is the component, first component of our vector. Then I have y2 minus y1. And then finally you would have z2 minus z1. And then there are your actual coordinates, okay, of your vector. And this is now assuming that the tail starts at the origin. And if you wanted to start it at, for example, P1, you can certainly draw that, right? That's just a translation of the vector, okay, if you wanted to have it. So I'll actually show you this, okay? So if you had and you wanted to be able to visualize something like this. So if I go back in here, I'm going to actually refresh this back up, so just to start from scratch. Okay, let me remove this. Okay, so here's my x, okay, my y. Notice that the way that it has done it, okay, so it's actually shifted. I have the negatives towards me, so I'm going to try to shift this over. Oh, it's not letting me. Let's see what's going on. Okay, so it just goes one by one. That's fine. All right, so this is what I have. I'm going to add my object. I'm going to put the point, and I just want to illustrate this to you. So let's say I have I'll go back to this point. Let's call this point P1. All right, up there. I'm going to put another point. So let's put another point in there. Let's call this P2, and then maybe let's shift this out to, okay, we'll shift it out over there on the Y. So now notice if you wanted to create the vector itself, so I'm going to put a vector right there, okay, and now notice the components, so from P1 to P2, so that's going to be, so 0 minus, so it's going to be -3, okay, within here, then it's going to be 3, then it's going to be 0. So notice it actually draws our vector in here. So it's, notice that it is on the negative side. So it's in the plane, okay, on the other side. And if you wanted to show it for yourself so that it is from point 1 to P2, you can actually adjust the settings. And here, notice the tail, it doesn't have to be starting from the origin. You can start it from, for example, the actual point P1. So I just put 3, 0, 0. Okay, let me just hide this out of the way. And then there is your vector, right, that you have. And you can do that with any points. So this isn't really anything magical, but it's kind of neat to be able to see it as you see there on the screen. So within that, so that is how you would actually find, okay, a vector between 2 points. Now, if we want to find the magnitude, so this is, something which I hope you still remember. So in terms of finding the magnitude, well, the magnitude in 2 dimensions, right? So for a vector, so as we had this, so if this was my vector, and let's say I had, so this was Vx, and then this was Vy, or you can use whatever variables you want in there. If I want to know what the magnitude of this particular vector is, you of course should recall that this is just the square root of the components, so squared plus, it's going to be Vy squared, and that just comes from understanding the Pythagorean theorem, okay, so way back. So it's just a matter of a triangle, right, that you have. Well, does this extend to 3 dimensions? And the answer is yes. So for instance, if this was actually 3 dimensions, okay, in here, and you wanted to find what the magnitude is, all you're doing is you're going to be adding the z component and then also squaring it. And in 3 dimensions, this is actually relatively simple to think about, because you do have your x, your y, and you can find out what the actual kind of hypotenuse between them is, or at least the hypotenuse, what is the actual magnitude of those. And then you can take that magnitude, okay, and then work with the z component, and this is exactly what you're going to find. So the extension is rather nice that the magnitude is the same. It's just adding an additional component. So in terms of your third dimension, and that's how you would find it. And you can do that, for instance, if you wanted to find the magnitude of this, okay, of the vector between the 2 points, okay, so between these 2 points, then you are going to find that you're going to have to take each component, so x2 minus x1, square it, plus y2 minus y1, square it, okay, and z2 minus z1, and square it, and take the square root, and you have the actual magnitude, right, of the distance between those 2 particular points, or whatever that magnitude is. Maybe it's not the distance, maybe it's a force, maybe it's something else. So that is the introductory video that I have for you. So we've covered kind of a few items. So in terms of plotting points, it's the same thing as 2D. Vectors, again, it's the same, right? So we can certainly utilize the Cartesian vectors. And notice I didn't actually use the geometric way because it's too cumbersome, right? In 3 dimensions, trying to find the magnitude would be fine. It's just the angle, and then describing the angle would be annoying. If it falls on a particular plane or an axis, then that's not an issue. But if it is actually 3-dimensional and has components of, you know, your x, your y, and your z, or your z, then it becomes too cumbersome. So the Cartesian vector representation is much nicer, okay? Or you're going to be using the base unit vectors, I, j, and k, to be able to represent it. So I showed you how the magnitude is still the same, how you can find the vector between 2 points. So it's just a subtraction, okay, between those 2 particular points. And then the vectors identical to 2D, except you have now an additional component. All right, so thanks for watching, and we will see you in future videos. So happy studying vectors in 3D. Bye, everybody.